Hi, in this video we will solve another word problem for related rates. The problem is a little bit long. You can pause the video and read it yourself, but I will go through it very quickly. So we have a rope which is attached to a weight. Let me sketch something here. So it is attached to a weight and then rope goes up, goes through a pulley and then comes down and exactly at the same level as the connection of the rope to the weight, we have a worker keeping the rope. The distance of the connection point to the ceiling is 40 feet. So as a result, the length is 80 feet. Then the worker starts walking away from the weight. What happens is that while he pulls the rope, and as he pulls the rope, the weight goes up. Yeah. Now the point is that, okay, what is the rate at which the weight goes up or rises when the guy is walking away from his original position at the rate of 2 feet per second. Okay, so the question may seem a little bit complicated, but let's just start identifying the variables. The two things that we have the rate of change for, one is unknown, one is known, is first of all the distance of the worker from the original spot. So it will be this. So this is how far the worker is from his original place. So this, let's just denote it by D. The second thing is that how far the weight is already gone up. So how far the weight has gone up. So let's denote that one by H. What we know that dt, the rate of the distance and the rate at which the worker goes away, the distance increases, is what was that, 2 feet per second. We are looking for dH dt when d is 10 feet. So we have to find at what rate the weight is rising. Very nice. So we have to find now a relation between D and H. Well, if you look at this, it may seem again a little bit complicated, but the key point is that you have to see this right triangle. Here is D. Up to some point the weight is gone up. This is H. And then here you see the rest. Let me bring in red. So this and this part, the red part that I'm tracing, is the total rope. Yes, and these are going to add up to 80. Yes, so let me call this guy L here, back to black. Now we know that, let me call this part L. And here we know, because the total height is 40, so 40 minus H will be that piece. And as a result, you see that L is 80 minus 40 minus H. So out of the total length AD, 40 minus h is before the pulley, the rest, which is L, is after the pulley. So in other words, L is equal to 40 plus h. Very nice. But why is that important? Because when you have right triangle, Pythagorean theorem is the one you have to use. D squared plus 4d squared is equal to L squared. But we know that L squared is, so we can write it in terms of D, in terms of H, 4D plus H squared. Very nice. We have now a relation between D and H themselves. We can find the derivative of both sides with respect to time. This will give us 2 d dt d plus 0 equals to 2 4d plus h dh dt. And well, basically we have all the values. Well, we know what is this guy here, this guy. Well, to be honest, we have to be careful here. We have to know what is h itself when d is 10. So note that when d is a 10, then we can use this equation. And we can write that, well, 100 plus 4d squared equals to 4d plus h squared. And then from there, you see that 4d plus h is equal to square of 1700. And you can take the 4d to the other side, but what you need to know is that 4d plus h is what we need to know here. So now that we have all the values, plug in the values. And solve it for dh dt as 2 times 10 plus 0 equals to 2 times root 1700. And dh dt. Here, this is 40 equals to 2 root. Well, root 100, the 1700, you can write it as 10 root 17. This is just a simplification, better to know it. And then from there, you see that the h dt is equal to 4d over 20 root 17. And this can be simplified. 2 over root 17 feet per second is how the height of the weight grows or rises. Again, you have to find the relation. The main part in this question was identifying the variables and finding the relation. From that point on was all like the other ones.